right? So we're solving some equations today. All right? Usually what happens, if it's an exponential equation, we're going to turn it into logarithmic. And if it's logarithmic, we turn it into exponential. Now we just go ahead and solve it. It's simple. All you got to do is stay focused for a few minutes. All right? So, an exponential equation is an equation containing one or more expressions that have a variable as an exponent. To solve exponential equations, try writing them so that the bases are all the same. That's what we did when we tried to do it mentally before I showed you the change base when we could do it in our calculator. Or take the logarithm of both sides. You'll probably do that second one. You can do that for everyone. This one you can't always do because you can't always write them with the same base. All right? So again, if the bases are the same, then this exponent has to be equal to that exponent, is what they're saying. The base won't be 0 or 1, but it'll be a positive number. And then if two numbers are equal, then I can say log of A and log of B would be equal. Again, A would be a positive number, and B is a positive number when we do this, all right? So, I'll show you both ways for this one, because this one we can do both ways. I can write both of those numbers, those bases, 9 and 27, with the same base. Okay? So that's the first way I'm going to show you. Okay? 9 is 3 squared, and 27 is 3 cubed. Okay? The rule is, for these exponents, is to multiply the 2 and the 8 minus x. So 2 times 8 gives you that 16, and 2 times negative x gives you that negative 2x. And then 3 times x is 3x, and 3 times negative 3 is 9. 3 to the 16 minus 2x power equals 3 to the 3x minus 9 power, means those two powers have to be equal then. Then you just solve for x. Okay? So, if you can write the two bases with the same base, this is the way you can do it. All right? And then you finish it up. You know, if I add 2x, I get 5x. If I add 9, I get 25. And then I divide both sides by 5. That's where the 5 comes from. Okay? The other way is taking the log of both sides. I think that's on this side. No, that's just that way. All right. There's a check. Okay? The other way to do that, let's go back to here. All right? The other way to do this is, oops, let's do this. See if I can pull that down. Yeah. Okay, the other way is to take the log of both sides. If that'll go away, I can extend my page. And just put log in front. So log of 9 to the 8 minus x equals log of 27 to the x minus 3. Okay, what's the rule about these exponents? What have we learned that we could do with them if they're up there? We don't like them up there.
Bring them out.
Move them out front, right? Bring them down and move them out front, right? So I could rewrite this as 8 minus x times the log of 9 equals x minus 3 times the log of 27. Okay? You all right with that? That's a rule we learned, right? Now, oops, I forgot to put my 9 there, sorry. All right, how do I move this log of 9 over to the other side? I want to get it to the right side there. Divide, right? Very good. Okay, so these would cancel, right? And I got 8 minus x on the left, And over here, I got x minus 3 times, so I'm gonna put it in parentheses, because I'm gonna end up having to distribute it. And then I put that in my calculator, which is 1.5, I believe. Let me check. Remember, when you put log in, all right, it gives you that left parenthesis. When you put 27 and close it off, all right, remember to do that. I think some of you might have forgot that on your quiz if you messed up. And then log a 9, close it off, all right? All right, so there's our 1.5. Just wanted to show you that, how I got that. Okay, now I distribute the 1.5. So I got 8 minus x equals 1.5x minus 4.5 when I distribute. All right, I'm going to add the x to this side. What's 1.5x plus x? 2.5x, right? Because there's a 1 in front of that. What's 8 plus 4.5? 12.5, right? What did we say that was, 2.5? And then divide by 2.5. And what do we get again? We get 5. 12.5 divided by 2.5 is fine. Same answer, right? Okay. So this is the one you'll probably do more often. Because you can do it this way every time. Just put log in front. Whatever exponent's there, you move it out front. Take the log on the left, divide it over with the log on the right, and you'll get a number. And then you'll be down to an equation with just x's in it. And then you just solve for x. Okay? It's not much. So I just quit being so lazy. All right? I can't write 4 and 5 with the same base. Okay? So what do I have to do to both sides? No. No. What was the second way I just showed you? Log both sides, right? Put log in front of both. That's how you got to start. Wendy, wake up. Okay? What are we going to do with that x minus 1? Move it out front, right? Yeah. What are we going to do with the log of 4? Right. Divide it over so it gets on the other side with the log of 5, right? Okay? Whatever that answer is, I'm going to do what to move the 1 over? Add it over, and that's my answer. All right, so log of 5 divided by log of 4 is 1.161. So when I add 1 to it, there's the 2.161, which is the answer. You're not always going to get nice whole number answers. Okay? So I substituted in my calculator. Again, that's an approximation because we rounded it. All right? So 4 to that x, 2.161 minus 1, which is 1.161, is 5. It's really close. You know, it's 5 point, you know, if I didn't, you know, round it, it would be exactly 5. Okay? So that's probably the way you're going to do most of them. Because you don't have to try to think about, well, can I write both bases with the same base? Just go ahead and take the log of both sides and do it that way. All right, you guys try this one, please.
Everyone just like right there.
No, as my, as first graduate.
Yeah, because you may have
We want to get to last time. And
You don't
then, so that was fine. So that's what we did. And we only wanted to 21. So we got silver. And then we went against the one that we lost to, like, absolutely terrible, the worst team. And we lost to them.
Then, two X equals that. Well, it's too much work. So much work. So keep working. Really?
Yeah.
Good job.
Yeah.
Why don't you? I thought you were working on that issue. You don't have just a, you just need a regular one now. You don't need to have one of these. A regular scientific calculator has logs. Okay, that's right so far. Now move this over. Beautiful. No, do it. Right? So finish it up. Good. We understand.
Yeah.
That's the main thing. Danny, what'd you get? 3 over 2, 1.5 is correct. Any questions? Okay, again, this one we could rewrite this as 3 to the third. That other base, but just get in the habit of taking this out front and the log. Divide by the log of 3, one on the left, take it over to the right. And when you put that in your calculator, you get 3, and then you just divide by 2. You get 3 halves or 1.5. That makes sense? Okay, again, when you put this in your calculator, log 27, make sure you do what? Close it, right? That's where some of you, I think, made a mistake in your quiz, if you made a mistake. All right, let's do that one. I had a 0.2 after it. Oh, you just rounded it. I would have just hit divided by 3 there and then rounded. But I don't know. It doesn't tell you what it goes to, right? Oh, you were checking it. You were right. Yeah. That's right. And then what you would do, what? Yeah. Job. So
Of course I did.
All right, so what do you guys get? 1.302, right?
Yeah.
So the 3x goes in front times the log of 2 equals the log of 15. Divide by the log of 2. And you got 3x equals log 15, close it, log 2, close it. You got that, right? Oh, that's not right. Had an extra log in there. All right, you got that 3.90. And then divide by your 3 and 1.302. Oh, well, that wasn't 1.9, was it? I forget now. 3.9, sorry. Okay, making sense? So we're turning exponential equations into logarithmic, all right? Now, we're gonna go the other way. We're gonna have logarithmic ones, and we're gonna turn them into what? Exponential, okay? So logarithmic equation with the logarithmic expression that contains a variable, you can solve these by using properties of logarithms, okay? So if these bases are the same of whatever this is, you know, some number or some expression, then the two expressions are equal, okay? So I don't have a log on both sides of this one though, do I? So how do I change this to exponential? What's the base when I write it exponentially? 6, what's the exponent? -1, very good. What's it gonna equal? 2x minus 1, that's what we do. All right? So the base is 6, the exponent is -1. Remember, that's what logs are, the exponents. And then you just solve it. Simple, right? All right, so what do I do now to solve? Come on, talk to me. Nicole, what am I gonna do? I want to get x by itself. So what am I gonna do with that? Add it, right? That's gonna be some decimal, or what fraction is that? Olivia? What's that fraction? What, 6 to the -1? Come on, peeps. What is that? What do we do with that exponent to make it positive? 1/6, yeah. Right? So what's 1/6 plus 1? 1 and 1/6, right? All right. Since it's a fraction, I divide or multiply by the reciprocal of 2. Oh, I put that 7/6. Sorry, that's hard to tell. That's a 7. Right? 6/6 and 1/6 is how I got 7/6. And then 7 times 1 is 7, and 6 times 2 is 12, right?
Yeah.
Yes, no, maybe?
Yes, you're correct.
Am I correct?
You are
Finally?
Yes.
All right. Mr. Lippy, you want to teach them more? If you remember how? All right, you guys try that one.
Wow.
Oh, great, great.
Hey, condense it, right? What's the rule? If you have 2 logs you're subtracting, you can make it a single log by doing what? We just did it. Make it a single log. How do I turn 2 into 1? If it's subtraction, I do what? No, we don't take subtraction addition.
Yeah, I got it right.
Hey, what was that?
Divide.
Divide, right?
I said it.
All right, so here, I'll help you with that since we have to divide, right? So what is the division problem? What's the division problem?
100 over X plus
100 over 10.
100 over
X plus 1.
x plus 1. All right, there's the single log.
I am so scared of that.
This is why what's
Yes.
John's not, he's got his mask down.
I am terrified of that.
That's gonna be on you. I honestly do.
Come on, let's go. Do this now, just like we did the other one.
Log 4.
No. Turn it into an exponential problem now.
I'm confused.
Oh my goodness.
4.
You guys, from one slide to another, you guys just let it go right out of your mind. Yeah, go ahead. What do we do with the 6? Well, what for that power, right? Equals the number, right? So we change it from log to exponential. So, same thing, we got a log, we're gonna turn it into an exponential. Come on, TP. You're zoning out on me. No. Do I have to put 4 to the first in my calculator?
No.
What is 4 to the first?
4.
4, come on. But you stop yourself, right, Scott?
Yeah.
All right. Yes, sir. Come on. Grace, come on.
Yeah, correct. Now get that out of the bottom.
They're one.
Maybe. That's not funny. All right. So you guys already told me 4 to the first is what? 4, right? Come on now, what do I gotta do to solve this? Grace, it's basic algebra 1 now. What do I gotta do to get that x plus 1? Come on, let's focus. Multiply. So we're gonna multiply by x plus 1, right? All right, can you finish it now?
Yes.
Distribute 4.
Wow, you're like body shamer.
We like you, Ryan.
Body shamer.
Maybe not.
Now what? Come on, Pete.
Minus 4.
Thank you.
Yeah. Minus 4.
So what do we get? 24.
No matter how many times.
All right? So what is 24 plus 1? 25, right? So, just to check, right? 24 plus 1 makes that 25, right? How do I do log base 4 over 100? How do I find that answer? Danny?
Divided by log 100, divided by log 25.
Well, 4.
Is that right?
Right. I'm doing this problem right here, okay? I mean, you're right, it's log base 4 of 100 over 25, which is, yeah. But I'm just doing each one separate, okay? So log of 100, right? Divide by log of 4. Isn't that what the rule we just learned? All right, we get that. All right, minus log of 25 divided by log of 4. What should we get? 1, right? We got the right answer. Okay? We can check if you want to check. All right, try another one. So it was subtraction. What did I change it to make it a single log? Division. What if that was addition? What would I have done? I would have multiplied, right? All right. Try that one. That's because you're not focusing. You're just letting your mind wander.
I'm trying to do.
Come on, you guys can do this.
You can. Not only
Literal.
Good start. No, that stays over there. Just that came over.
Oh, the X thing?
Yeah, that was. The 40, that's not there. No, it's just right beside that.
I can do this.
Right there. Put it up.
John Joaquin, it's working.
See that? Right, so far, keep going. Move that over there.
Oh, that's right.
That's what you thought you were gonna do, right?
Oh, no, I did that, but I raised it.
What'd you get?
0.
Mr. Hank.
The one that's,
Good. Move.
No.
Okay, you move that up, right? So why did you drop the log? Well, let's not do that yet. Move that over there, then turn it into the other. Yeah. You can't take the X over the front, just the 4. Okay. It's not an X
Wait, I don't know.
What is, you know, I don't.
Kind of right. Because saxophone, now move that way. Story, this X is just a normal X, it's not an X. Okay.
Then did
No.
you divide by 1.5? You're gonna get the I don't know if that's right or wrong, but it seems reasonable, not
Because the X is after the log. No. Sure, but I told you, move the 4 over there. Zito? What'd you get? Why are we done? Let's go, finish. Right now, you got 1 minute to finish. 59, 8, 6. Just put in the calculator, come on. Never mind. You're clueless. All of you did this, which was good. Then you got stuck. There's no reason to get stuck here. We all okay with that? Why can I do that? Why can I do that? The 4 was an exponent, right? The property or the power rule of log says I can move that power out front. Now, if this was just 4x equals 8, what would you do to solve for x? Divide by 4. We'll do the same thing. So now I got log base 5 of a number equals 2. Now it's really easy. Wendy, now write it exponentially.
Okay, so 5 is second.
What's x? You guys don't even need a calculator. What is it? 25. Yeah. Okay, so here's what we're going to do. When we have a log equation that we have to solve, and there's an exponent, we're going to move it out front, and then we're going to do what to take it over? Divide it. Get it just log of something, and then write it as your exponential. Okay, so this one has addition, so what should I do? Make it 1 by multiplying them, right? So log base 12 of x times x plus 1 equals 1, right? You okay with that? You got to have it a single log first before you can solve it. Now, what's the exponential problem now? When we had it a single log, we knew it was 5 to the second, right? On that one, what's this one? 12 to the first, right? X times x plus 1 equals 12 to the first. Okay? Trent, now what? Good. What kind of equation has it turned into? A trinomial, yeah, but what do we call those trinomials? Got a certain name, starts with a Q. Quadratic. Cubic starts with a C. Who was that? Is that the English teacher's kid?
Oh, wow.
Cubic starts with a C. He thought it started with a Q. You got it.
It sounds like you. What?
Wow.
It's Monday on a Wednesday.
Yeah, it's Monday on a Wednesday, I get to say.
Literally, it sounds like cute.
What's your 2 answers?
That's the music cute. Using context.
Explain.
Oh, wait.
Right?
Yeah.
Is this anything new for us?
No.
No. You can't forget about everything you've learned so far. All right, so let's see if these work. If I put -4 there and -4 here, I get -4 times -3, which is what? 12, positive 12, right? Is log base 12 of 12 equal 1? Have we learned something? That if these two are the same, they do what to each other? Cancel. That works, doesn't it? All right, so that one was okay. What's 3 times 4? 12. So those both should work. Sometimes they both don't work. Okay, but this one worked for both. All right, so what did we start with? We started with 2. All right, if we have 2 logs, if it's addition, we're going to change it to a single log by multiplying them. If it's subtraction, we're going to change it to a single log by dividing them, right? Once you get it as a single log, then you change it to exponential. 12 to the first equals whatever's there. You know, we got this one. We moved the 4 out front, took it to the other side. We got 5 to the second equals x then, right? This one, we had to change it to a single log. We divided because it was subtraction. And then 4 to the first, right? Was the 4 equals that fraction, and then we solved that equation. Okay? This one was already a single log, so we just went right away to the exponential. These, we got to turn them into logs, right? Put log out front of them. Then we moved it out front, right? Divide the log over to the other log. So then you're done with your log stuff and you've got an equation with an exponent. Okay, so those are the 2 types you got to do. All right, what's your homework? Coming here.